kiln casting, demystifying the digital. And so we're going to talk a little bit about how to approach making a kiln cast glass piece through the Rhinoceros software process, through 3D printing, the PLA plastic meltout, and then, maybe a little bit about how I finished this object. So just a little bit of background on this object. This is a 3-component interlocking project. And so the first major project in my class is a project that students are expected to make a minimum of 3 components that interlock, exploring the potential of 3D printing, the idea of how 3D printing also deals with expansion and contraction like glass, and then the accuracy of the process. And so one of the things that I'm interested in is exploring how color can also be a component to sort of transform very simple objects. Just as an example, I'll leave these open, but I have essentially the same object as a 3D print. And then behind me is actually a 3D printer that's printing the same object, not at the same scale, but it gives you a sense of how the 3D print process works. And I'll take you through how all of these can connect to a kiln cast glass practice. So I'm going to shift to the computer and show you some, I'm not going to dig too deep into the software, but I'm teaching a class. Jen Blanzina is behind me, one of my students in the workshop, a very accomplished artist. I also have John Reese as my teaching assistant. John is the studio manager at Bullseye Glass. And so having really accomplished artists and having the opportunity to teach artists new tools for their kiln casting practice is a really exciting opportunity. So I'm going to shift to the computer and just go over some really basic things to show you what the computer can offer as a kiln cast tool. So I've been teaching 3D modeling or some form of 3D modeling for over 20 years. I've worked with several different 3D modeling softwares. I also teach this at a university, Grand Valley State University in Allendale, Michigan. But one of the things that I like about working directly from 3D printing to kiln casting is thinking about how you can combine hand skills and digital skills. And a lot of the students that come to my workshops are very competent artists, have lots of hand skills, but are interested in the potential of incorporating digital skills. And so when you're incorporating digital skills, why would you do that? So it's very easy to scale up objects in the computer. It's very easy to alter objects. So here is on the computer in Rhinoceros software, here is my project, the 3 components of it. I set this up exactly how I was planning to kiln cast it. I put my reservoir built into this object. There's lots of different ways to cast something like this, but my goal here is to give you, an example of how this was made, how the 3D print was made, and what's happening behind me. So this is 3 components. To just quickly show you how I would make something like this, I'm going to just jump over to a larger window. I love the virtual space. Nothing in this space right now has scale, so it feels very plastic to me. Once we start printing, then it has a scale. So I'm just going to generate a cylinder, which is essentially generating a circle. I can extrude that circle in either direction, and I have a 3-dimensional object. I can add to that circle with boxes, and I'll jump up to a top view here, jump over to my object, and I can come over here and I can extrude them in my perspective window. So now here I have one object. I'm going to make multiples. So again, I know for artists that have never worked with these tools, they tend to feel more you know, people in the class is about demystifying the tools. So the goal here is to get people to see the potential of this in their own practice. So I have a very simple object here. I'm going to, I'll play with this just for a minute. I'm not going to spend a lot of time in the Rhino software. So here's my object from the side. I'm going to bring these up, make them longer. I can also rotate these objects so that they're not just aligned all the same. Let's leave that one the way it is. So I'm also going to take, again, making renditions of things, copying things is very easy in this software. So I'm going to copy this, and I'm just going to move another version up. And so now I have two of the same. Maybe if I go to perspective window, it's a little easier to see. For those of you not here. So here, this is a little different than what I was doing that's on my table, but I'm going to select these objects here, and Rhino and many 3D modeling softwares have these tools called Boolean tools. Boolean tools are based on mathematical formulas. They allow us to assemble things, but also to cut and shape things. I often talk about with my students that 3D modeling is a process of additive and subtractive processes, very much like this object in front of me. And so the thing that you can also compensate for is you can shrink things. So I know that if I 3D print something and I'm using an object to cut something, it's going to be the exact same size. So if I wanted to, I could shrink this a little bit. Shrink this another way. Okay. And I'll leave that one just the way it is for fun. So I'm going to select this and these three cubes, and I'm going to assemble them. You might see that the geometry within this project changes, and so did that work? No, didn't work. So let's try this another way. This is the other thing about 3D modeling. Sometimes you have to do things a few times or a couple of different ways. So I'm going to try this, and this, and then hit return. For those of you watching, you might notice that the geometry on these changed, and now this is one object. And so I can then subtract this from this, which gives me an exact cutout of the object. And so I'm going to, first, I will copy this and put it on the clipboard. Actually, how do I want to do that? I'm going to actually take a step back here. Edit, redo. Okay. So I'm going to cut this out really quick. Difference this with this. And so I see. Okay. So difference this with this. So difference this. So now I have an object that has the holes in it. I copied those holes, the cutting objects, and put them on my clipboard like you would in Microsoft Word, and then I can paste them back in. And so now that I've pasted them back in, I'm going to attach them all to the bottom plate, and Then I have my two objects that would be ready for kiln casting. So now I have two objects that I could cast that would fit together, and I could work with two different colors. So the next thing that I want to show you, that's just a quick way of thinking about how this project could be accomplished. I will say this, that my students in the workshop have infinite ways that they solve this problem or they consider this problem, because everybody has their own aesthetics. You can also hybridize this project where you actually work and attach wax to the 3D printed parts, and then you can melt them out as well. So I'm going to minimize this, and I'm going to jump to my slicing software. And one thing I'll say, there is an infinite number of 3D printers. My experience has been over the last couple of years that some of the best and least expensive printers are the bamboo printers. Anything that I'm showing you today, I have no affiliation with, other than I'm teaching at the Corning Museum. But we have a bamboo P1 printer behind me, and on the screen I have the bamboo slicing software. So what I'm going to do is I have several options for slicing an object. And so for slicing, what you're doing is you're taking a file that was generated in Rhino software. It was exported as a .stl or stereolithography file. Rhino turns the surface of this object into a triangulated mesh that can then be sliced. And if you think about 3D modeling as, basic, or 3D printing as a hot glue gun, a very strategic hot glue gun, you can approach this process where you actually are thinking about how you're building linear line after line after line strategically with your 3D printer. So to slice this, to scale this is very, very simple. I really love this software. So I can change the scale of this. Now it's 100 millimeters. I'll just make it 75 millimeters tall, which is approximately 3 inches. And then if I slice it, if I slice my part, there's a couple of other steps. Because you have cantilevered elements, Rhino, or the slicing software is going to want to say, well, you can't support those parts without having supports. So I will add supports, and then I will slice the plate. And it's that simple. So this object, it's now saying approximately 1 hour and 56 minutes total time to print this at 3 inches tall. And so if I, for example, and you can see there's tree supports here supporting this object as it's being built. If I go back to my original window and undo that, and I enlarge this by, say, let's say 100, let's not quite double it. Well, we could double it and see what the timing is. Go to 150. It's a much larger object, so everything is larger, so exponentially. It isn't just going to double the size, the time to print, it's probably going to triple the time to print. And when I say slice plate, that's now at 7 hours and 11 minutes to print that part. So we are wireless here, so I can actually send my prints to the printer wirelessly, and it's a very seamless process. So I could talk about now what's happening in the 3D printer. Can open up both of these. I don't know if that's helpful to see. Take this off. We have these enclosed printers like this because for certain kinds of geometry, certain shapes, maintaining a very even heat is essential. For this project, it's not so critical. So what's happening here? We have a plate. This plate is heated so that the material in the printer is being extruded at about 415 degrees Fahrenheit. And so it's going through an incredible expansion and contraction process. And so things that have hard edges tend to want to curl. By having this heated, it maintains a certain geometry and pull on the object. The layer thickness, we're talking about generating an object that's about 200 layers here. The layer thickness is about 0.2 millimeters. So if you want something incredibly high resolution, I mean, I can still feel the layers on there, but if you want something with incredible high resolution, then you can actually make the layers thinner. So imagine that if you want to visualize this, a standard layer thickness, think about stairs. So stairs are like 6 to 7 inch rise from one step to the other. If you went to a higher resolution, you could go, instead of 6 or 7 inches, maybe 3 or 4 inches. Or in an extreme case, like 1 inch. So you have, the finer the layers, the smoother the object. Especially if you're making an object that has, certain very, smooth edges like this. And this has been cold work, so some of the 3D print material has been removed from here. So for an object like this, and then a little bit more information about the 3D print process. So for my class, we use this clear filament. So this filament is a standard filament that can be used for 3D printing all kinds of objects. And so why do I use this filament for my class? Because the filament allows you to melt it out of your investment molds. So I have a couple of examples here. So this is my PLA melted out of my mold that's clear. Here is PLA melted out that has colorants in it. And so what happens when you have colorants is that it has stabilizers and all kinds of other things in it that make it more difficult to melt out. And so I just wanted to show you a couple of examples of, in this material, when you melt it out, it's just brittle, but it comes out. And my kiln schedule for melting this out, just a simple way of thinking about this, because you're heating up a mold and you're melting out a material. My kiln schedule is, and I have an example of a couple of examples of molds. A kiln schedule for a mold like this to melt out my PLA, and I use this orange PLA just as to give you a little bit more of a visual aid. A kiln schedule for this, we put this in the kiln, we put aluminum foil underneath it, we stilt it so that the material has a place to go, and the aluminum foil is so that the PLA material doesn't go into the kiln brick. Lands on the aluminum foil and does this, a little bit of aluminum foil sticks to it. We go 10 degrees per hour up to 500 degrees, which is a little bit hotter than the melting temperature of the PLA. And then we hold at that temperature for 5 hours. And I'll talk a little bit about my mold materials. I'm going to make a mold for you and talk about why we use the mold material we use. But this mold material allows us to essentially twice fire the mold. So I'm firing it, I'm getting this material out, I'm going to flip the mold over, I'm going to fill my mold with glass, I'm going to put it in the kiln, and I'm going to do a traditional kiln cast glass firing. And this mold is essentially this object at a slightly smaller scale. This is my mold with the PLA melted out. And so this just gives you a visual of these two objects. I know it looks a little like an orange juice maker. The shape of it is a little like an orange juice maker, or squeezer, but it gives you that kind of idea. This was cast into this orientation. This object had an as-cast surface. So if you're familiar with glass casting, I had to cold work this surface to grind it down to flatten it. A couple of other things. For our mold materials, just to not step too far ahead, our mold material that we use in my workshop, and again, I have no affiliation with any of the materials I use other than I know they work, is a material called Ransom and Randolph glass cast. This is a commercial investment material that a lot of glass casters use. Because we are exerting an incredible amount of pressure and heat on these molds, and we're doing it twice, we really need something. This mold material has everything in it that you need. So it has plaster, silica, grog, kaolin, very fine fiberglass. So even if I get a crack in my mold because I have fiberglass in the mold material, it holds the molds together. That fiberglass is one of the things that keeps the molds together during that twice fire process. This PLA actually expands a little bit as it's melting out, which it exerts an incredible amount of pressure on this. So I'll talk a little bit more about the mold making, but I just wanted to be clear that this is the mold material we use. This is a material that you can buy commercially. Artists can buy it. It's shipped typically out of Toledo, Ohio. And so I'm just going to remind people of the melt-out schedule. So these are small molds. So for a melt-out schedule, we made the molds, we let the molds cure for an hour, we take the cottles or the forms off, and then we put these in the kiln. And so for a mold like this, I would go 10 hours up to 500 degrees, and then I would actually hold at 500 degrees for 5 hours. If I had a mold, for example, that was 4 inches larger in every dimension, I might hold for 8 to 10 hours at 500 degrees. And so once these molds come out of the kiln, this mold is actually pretty, you may not be able to see it, but it's actually pretty delicate. So you want to be really gentle with this mold as you're handling it. And the other thing, the other component of this is, I just wanted to show you that, and I know that I have these conversations with my students, you know, the 3D print that's on the surface of this gets translated into the surface of the glass. So you actually sort of transform the optics of the glass with the 3D print. And so this material will pick up fingerprints and translate the investment material. Whatever texture or surface you have will be picked up by the mold material. And before I jump in too far, I mentioned this in the 3D model, but I actually put my reservoir on my piece like this. So I cut this off just to make it easier to fit all back together. But I find, we don't do this always in our workshops, but I find that putting the reservoir on the object just simplifies the 3D print process. So all of this can be done, all of it can be printed, and then you don't have a lot of clay work, you don't have a lot of wax work to set this up. I'll leave these open. Maybe this is helpful to see these objects sort of side by side, like that. They just want to keep rolling because they have a lot of weight behind them now. But just so you can kind of get a sense of what the 3D print and the So you get a sense of what the 3D prints and how they kind of work together. So there are limitations to this process. You know, I spoke about the PLA material. You know, you really want to work with a PLA material that's clear because it melts out more efficiently. You really want to work, you know, you want some ventilation in your kiln room. If you're working with this material, you will smell the material a little bit at temperature, so you want to be able to open up your garage door or some kind of basic ventilation. For my mold that I'm going to make today, I'm just going to make a mold of this. So I have set up a fairly simple coddle attached to a bottom board. I like to work with bottom boards because I can move things around. You know, we have 6 students, myself, and my TA, John Reese. And so John is also making work while he's here, and being able to have efficient mold space is good. So I'm just going to kind of show that I have already made something for this to stick to inside the mold. So I have a plasticine base, and then I have chicken wire. Chicken wire is there. There's 2 reasons for the chicken wire. Chicken wire is there for multiple reasons. One is that it helps with the expansion and contraction of the mold material. It just gives more integrity to the mold as it's going through really significant expansion and contraction, and it's happening at 2 different places. So in our first melt out process, the PLA plastic, which I should say is also not a very strong plastic, it's a corn-based plastic, so it's one of the reasons why it melts out so easily. It's not designed to be a very resilient plastic. At that lower temperature, that PLA is exerting a lot of pressure on the surface of the mold, and then at the higher temperature, the mold is going through significant expansion and contraction, and so the chicken wire gives it a lot more integrity. So I'm going to press this down. I wish this was a little bit shorter. I'm just going to press this down into my clay, and that'll prevent, you know, the mold this from floating. So anybody who's ever done kiln casting before has likely had this happen, where you have a 3D model, or that could be wax, it can be any kind of object that you're making a mold of, and because it's a completely sealed object, it's buoyant. And so as soon as I pour water in there, the reaction of this is to want to raise off the platform that you have it attached to. So it's really important that you have this attached in some way that prevents that. And the other thing to consider, you know, the bamboo printers are excellent at making watertight objects. What I find is that in some cases the other printers do not make watertight objects. So when you pour investment material onto the objects, you can get investment material inside of this, which can cause significant problems for casting. And so one of the things that we talked about this in my class yesterday, one of the things that I like to encourage the students to do is to actually just dunk these in water. If you don't trust your printer, especially some of the older printers, which aren't calibrated as well anymore, you can have delamination between layers. And if you get significant bubbles popping off the surface, then it's an obvious issue that you need to go in and maybe use a little bit of wax to kind of patch that surface. So I actually really like the 3D print surface, so I don't tend to do a lot of changes or alterations to the surface of my object. I try to, and when I was cold working this, you can see, you know, with especially these clear objects, I really didn't alter the surface of these very much. I had to do a little bit of finishing on the outside of this. So let's make sure that doesn't hit. There we go. So I'm going to press this in, and I'm going to talk a little bit about the mold making steps, just so you have, and to be clear, what I'm making is exactly what you see here. So I'm generating this mold that would be ready to go into a PLA meltout. And then the next step would be to add glass and do a kiln firing and to generate an object that looks just like this. So I'm going to press this down. Make sure that it doesn't float. And then I'll talk a little bit about my mold making process. Okay. So the Ransom & Randolph 910, I've got my mold materials here that are weighed out properly. My Ransom & Randolph 910 is the strongest of all the Ransom & Randolph materials. And the reason we use this material, it's very much a powder material. It's actually green. It has a colorant in it so that you can tell the difference between this one and the 4 or 5 other ones that are sold by this company. But it has all the materials in it, as I mentioned, you know, the kaolin, the grog, the flint. I have found that this is a really good material for the majority of the work that I do in my home studio. For many years I had a very small studio, so I didn't have room for all the variety of mold making materials that other people use in their studio. So I have these two. Whenever I mix mold materials, I'm always using a mask, so N95 mask. I mean, one of the really amazing things about Corning is that in our mold room, we have such great ventilation that technically you actually don't need to wear a mask if you're working directly in front of the ventilation. So for those of you at home, I absolutely recommend an N95 mask minimum. I also have a snorkel that comes to my mold making table at home that pulls the dust out of my studio when I'm working with this material. So thinking about how we work as artists long term with mold making, it's really critical that you follow health and safety practices. And then of course, wearing glasses or safety glasses while you're working with the mold material is important. So how do we mix this material? So there's ways to figure out the volume of this. I'm not going to spend a lot of time going through that process today, but we could figure out the volume of this. We can actually figure out the volume of this object in the 3D modeling software. I can figure out the volume of this cylinder that I'm going to cast in real time, or I could also create it in the 3D modeling software, and I could difference the cylinder here from this object, and I could figure out the exact volume I want. May sound complicated, but if you're really trying to conserve material, it's a great way to maximize your material in your studio. And it's to say that these materials are not inexpensive, and then shipping is also expensive. So it's a great way to conserve material. I'll put on my N95 mask. I'll try to talk very clearly while I'm working. Once I have all the dry mix into the water, I will shift back to, I'll take my mask off and talk through. It's 8 minutes to mix. Maybe time, I'm going to have John Reese time this for me so that I can keep track. And the reason why we want to time it, there's a couple of things. One, you're working with plaster. So you're going to mix and you're going to agitate the plaster for a minimum of 8 minutes. You really need the chemical reaction in the plaster to start before you pour it. If you pour this material too soon, all of these really great things in this material, like the kaolin and the grog, all fall and stick to your 3D print. And then they stick to your glass. And so it's really critical that you mix accordingly. If you're mixing large batches of this material, I've already pre-weighed this, so I have 2 pounds of water, I have 6 pounds of dry mix. It is a 1-to-3 ratio. So if you're mixing large batches, it's absolutely critical that everything is weighed, because you don't want to have layers of this material delaminate from itself. You'll end up with major flashing on your work.
Norwood, we also had a question on the live stream.
Oh, okay.
The question was, why do you prefer to use PLA versus a water-soluble PLA or
PVB?
Or PVB, sorry, or a wax filament?
I've had mixed results. I feel like we're not quite at a place yet with the wax. I mean, I've also, I'll take a couple of steps back because it's a great question. So I also teach bronze casting as part of my job at Grand Valley State University. So, and I've also taught several metal casting workshops, and I've had much more success with PLA melting out of ceramic shell. And it's really a burnout in that process because you're taking that process up to 1500 degrees to burn the material out before you can cast bronze into it. The other options, the wax filament, again, I've had pretty good results with it, but I also find that I really need to burn it out to get better results, which causes fumes and other kinds of things. PVB, we've had issues with. It is sometimes with printing and then sometimes with getting the material out of the mold. So an example of that, because it's a really good question, is if this was all PVB and I needed to steam it out, sometimes the bottleneck of that prevents the material from coming out. So the bottleneck of where this connects to this. Obviously I can make this bigger. In certain kinds of geometry, like this kind of object, it would just fall out. So it has I think that's the direction we're going, or some combination of the two different processes.
And I think where the question came from was for folks who may not have access to a kiln to melt things out, and still wanting to work with a 3D printing.
Yeah, no, it's a great question. And technically, you know, I only have 3 kilns. I do all kinds of things with 3 small kilns. A lot of my work is actually cast and fabricated. So, you know, I make castings in parts and then I fabricate them together because I have the constraints of my own studio. And so I think you have to figure out what is the scale you can work in your studio, and then work backwards from there. And then if you have one kiln, you can use the same kiln for your meltouts that you do for your kiln firings, which is what I typically do. Obviously, it's a little slower because if you're trying to do production casting in any sort of way, you can't accomplish that if you only have one kiln. So I'll put my mask on. Clearly, I haven't had to wear a mask too much here because we have such amazing ventilation. So every time you mix plaster, you put your dry mix into your water. It's pretty standard practice. I still see sometimes where people do it the opposite way. I've never really had success. I also want to just say that I've never had success using a drill to mix this material. I'm sure other people have. I want to be just really clear. I know other people have. But there's a lot of things in here that cause friction, and the material heats up. And as soon as the material starts to heat up, it wants to encourage the setup process. It's the same reason that I use room temperature water. If I use room temperature water, I know I have 8 minutes to mix it, and then as soon as I'm done, I pour it. So I'm going to just, I don't think I have. Can you pour that out for me? I'm going to use a smaller sieve. I like when I'm working with plaster to put the plaster as close to the water as possible. If I pour it in, and that's what I was just thinking about, I have somebody here with a camera who doesn't have a mask on. I don't want to be exposing everybody in the room to silica dust. So I want to be considerate. Same thing we talked about in the mold making room yesterday. We're all working in the space. We all have to leave at the same level of health from the end of our workshop that we showed up with. So I'm just going to add my material slowly. There's no rush here. So you have time. If you use hot water, then you have less time and it's less predictable. maybe this is interesting. I don't know if this is at all interesting. If you can see this, you can see the fiberglass little pieces. John and I have had many discussions, as well as Richard Whiteley and I have had many discussions about the different materials. I think that for me, not only do other materials potentially offer, like if you could steam the material out, then you're not asking the mold to do 2 firings, which is an incredible amount of stress on a mold. So I think we're working towards that, and I've been doing some tests on that. So, and as well as corning. So maybe in the next workshop, that would be the cool evolution of this process, is to sort of take the process to that level. And the thing that I love about digital technology is that it's finally becoming accessible. The printer behind me is $750. I have the lower end versions of these printers in my classroom at school. They were $330. They do essentially the same thing. And so the more people that participate in using digital technology in these processes, the more we learn. We are students of this process at every point. And so I want to stress that we are here to work together to learn more about this technology. And I learn a lot from my students in this process. Okay, so we talked about this yesterday. John had the correct term for this, so we're going to let this sort of slough a little bit. Which means that we let the water do the work for us. Give this just a few minutes. Move this out of the way. And maybe put these out front so you can kind of see those. Encourage this just a little bit. And then I'll let the water do its work. And then we mix, we agitate. Maybe have John, maybe if you can fill that up with water, then I can wash my hands off. Thank you. So I'm almost at a point where I'll start to mix. And again, once you start mixing, essentially you want to keep mixing gently through the whole process. And I'll talk you through some of how I'm going to pour it as I move through the process. Any other questions on the live stream that we should be addressing? John?
No, that was the only one that was brought to my attention so far.
Okay. That's great. That was a good question. So I'll start mixing now and then pour in 8 minutes. And I mentioned this before, but just thinking about how, like, when we're doing this in my class, generally when we're doing this in my class, we have several molds set up. This material does a great job of kind of sticking to itself. So if this happens to you where you pour your mold, and hopefully this doesn't happen today on camera, but when your mold material or your mold moves when you pour the material in, so you've got 100 pounds of material you're pouring into your mold, and your form shifts, sometimes that material pours out, but your model is stuck inside, and so this material sticks, that material that poured out becomes a gasket and seals it, and then you can pour the rest of your material in. And it sticks to itself in such a way that it generally does not cause any real issues. So what I'm feeling for in this bucket are the lumps. So I've never mixed this material in a way that I've never had lumps. You're pouring dry material into wet material, into water. It's going to fall in and absorb water slightly non-uniformly. And so I'm gently agitating this, mixing this. I'm not pushing my hands into this mix because that adds air to the mix. And it allows this material to mix in a gentle way. The other thing is, and I don't know if you can see this at home or in your studio, but I have some bubbles on the surface of this. One of the indicators that I'm getting close to being able to pour it is the surface tension of this material will change and I won't have as many bubbles on the surface of the material. I always think it's like, if you're learning how to do these kinds of things, it's always nice to have like an extra set of hands. We talked a lot about this yesterday in my workshop, where if you're working in the mold room, it's always great to have an extra person just because it adds a level of comfort, but you never know when you're going to need an extra set of hands. Things don't always work exactly the way you expect, and having that extra set of hands just gives you an extra set of support as necessary. Other things to think about, John, while we're in terms of the material. John's also done a lot of this PLA melt out in his own studio work, and I sort of introduced you earlier. Yeah.
What do you think about that? Did you talk about how when you scale up, things become much different and it's good to start small?
No, I didn't. That's a great idea. So that intention, in essence, like the students are making objects about this scale in my workshop, because 3D printing is a great bottleneck because it doesn't allow people to work too big in a 2-week workshop. I feel really strongly that the more feedback you get, so the more pieces you get out of the kiln, the more productive it is. And so this PLA, these 3 PLA parts, which equals this glass object, took 12 hours to print. If you were to scale it up, you would be making things in multiple parts. So you can glue those parts together with Elmer's glue. I've glued them together with wax before, but then you have a whole host of other kinds of mold making questions and problems. Take this mask off so I don't have to talk through it anymore. You have a whole host of other kinds of mold making concerns. As soon as you scale things up, wall thickness grows, weight grows, and then how you lift things in and out of your kiln grows. How you anneal things change. So it's really important that if you start small and you build some success into your practice, and then you start scaling things up and you start seeing some of those problems, it's a way of learning. If you just work large and you've never really worked with this process, I think you can find yourself kind of backed into a corner where you don't necessarily you can't really solve yourself out of the corner to figure out what's wrong in the kiln. So it's really important to kind of learn from working small before you work large. And it's very easy to take this project and enlarge it in the computer, enlarge it in the slicing software, and print it larger. But again, it's not necessarily easy to take that project and print and cast it larger. And one of the things I run into in my studio, I have a very simple studio. What I love about coming to Corning is that they have so many things for me to explore that aren't in my studio. But to do this process in your studio, 1 or 2 kilns at a small scale works great.
In about 2 minutes.
Okay. So we'll pour this. Something that you might not be able to see. Whenever I'm pouring a mold, I am trying to avoid pouring on the surface of my pattern. So it's very easy to trap air in small little bits of air if you're pouring directly on your pattern. So the idea is you'll pour right next to your pattern, and then the investment material will envelop your pattern. And so this material, you know, there's lots of different ways of making molds. So a lot of people hand build molds, a lot of people, you know, use all kinds of approaches to building molds. What I have found in my practice, because I have a lot of work that has incredible detail, and this material is a very plaster-rich surface, that casting it gets me the best results. So casting a block mold gets me the best results. I know other artists do it differently, and I really encourage you to experiment with it. So the only way that you're going to know what's successful in your studio is to spend time and experiment. With the plaster-rich surface, you can get incredible surface quality in your final glass castings. Like these pieces here, I did nothing to the surface except the underside that was cold worked. Nothing has been done to the surface. So that's freshly out of the kiln, just washed with water. So it's an incredible, it has a lot of potential. How are we doing on time?
30 seconds.
Okay. Any other things that I should be thinking about to encourage people to consider through this process?
Well, I thought your point about being able to scale things up digitally was great.
Mm-hmm.
I would add to that that there are other processes that you could use to go even larger than 3D
Mm-hmm.
printers, such as CNC
See.
milling.
Mm-hmm. Wash my hand off so I don't make a big mess over here. So at this point, I really don't have any bubbles left in this material. It's more like a thick milkshake. That should be the consistency. You can experiment with the density of this material, and so some artists will add more water so that the material isn't quite as thick. It helps with a little bit of the contraction of the glass. I find that sticking to a 1-to-3 ratio gets me a really good mold material, but again, everything should be an experimentation until you get it to work in your studio. So I'm going to pour this now, and so as I pour it again, I'm going to just remind people that I have chicken wire in here, and I explained, you know, what that chicken wire is for earlier. Generally, I set my chicken wire up to where I want to pour the highest level of the mold. I never want to have the chicken wire exposed, because when I have the mold flipped over and I'm moving the molds around in the kiln, I can cut myself. So I'll just pour this, gentle, even. Wow, I actually measured that perfectly. I never do that. I never do that. So I've got like that much left, and I just passed the chicken wire. So there's different philosophies about this. Sometimes if I know that I have this really well sealed, I will tap the table. You know, I have a rubber mallet that I use very, very gently. I also try to pour in a way that I'm not generating a lot of bubbles. So I generally don't have, in this mold material, because of its surface tension, it does kind of push bubbles out. But just be aware that if you come and start, you know, pounding on the table really hard to raise the bubbles off of the surface of this, you can actually release this from the table, which then causes all the mold material to be released. So I really want to encourage you to think about, you know, setup for mold making. Everything is in your setup. You know, like none of this stuff happens just spontaneously. And so just being careful and organized and stepped, you know, and planning. You know, the 3D modeling allows you to plan for a lot of the steps in this process.
Norwood, we did have one other question
Sure.
from the live stream.
Sure.
have you or can you use this method for multi-part molds? And it was a little unclear whether the question was about multi-part refractory molds or maybe casting parts of multi-part molds from 3D printed forms, those sorts of things.
It's a great question. It's interesting. I don't see why not. I think that the challenge is really that if you're using this process, it's like you have to be very gentle with the mold material. And so if you have multiple part molds, depending on how those parts are assembled in the kiln, how those parts get assembled and potentially disassembled if necessary becomes, I think, a more important question. So I don't really see why not. I mean, I have never worked that way in my studio. I mean, the way that I have worked in workshops is to generate individual components that then fit together as a larger unit. So it's a really good question. I think I would have to, like anything, I would have to experiment. But I think it's absolutely worth the experimentation to see if it's worth it. And then if you don't get, I mean, again, working at a small scale, what works at a small scale doesn't always work at a large scale. So, or doesn't always immediately work at a large scale. When I talk to a lot of other glass artists who are kiln casters, a lot of them will say, well, I tried this at a small scale and I enlarged it, and then suddenly I was having all these problems. And so then you have to figure out how to isolate your problems. Are your problems in your glass? Are your problems in your mold material? Are your problems in your kiln? And once you start isolating by maybe doing more tests, then you can start figuring out how to move forward with something that is at a larger scale. John made some pieces, I don't remember how large they were, but they were fairly large scale, and they would have been very difficult because of the architectural nature of them to make them, even if you went through the process of making a 3D printed part at a large scale and then making a rubber mold and trying to cast those in wax, because wax has its own issues with expansion and contraction. Like this kind of object cast in wax would have a different kind of problem because wax doesn't like to be flat. And so 3D printed parts afford you different kinds of shapes that would be not impossible to get in other processes, but have some challenges. So.
One other question that I have, Norwood, is have you discussed at all what happens after the work comes out of the kiln and how the mold material gets removed from the
No, I didn't. That's a great question. So one of the true benefits of this material is that unlike traditional plaster and silica, it has almost zero expansion and expansion when you rehydrate it. So for me to remove this material, and for my work, which is incredibly fragile, I soak my molds in water. I generally soak them in water overnight unless I'm being impatient. Impatience doesn't really pay off with glass casting. So I typically soak my molds, and then I use a tool that is not a metal tool, a small wooden tool, and I go in and I kind of pick the material off. And so there's two really good positives to that. One is I'm not exposing myself to free silica dust by removing the material without water. And then because the material doesn't expand, I don't have issues like if the material expanded between these areas, it could actually, probably wouldn't crack the thick one, but it could certainly crack these smaller ones. So the mold material it's a little bit more, the mold material actually is reacts a little bit more like, when I've worked with jewelers who then take their, after they've cast their parts, they just dunk them in water and the mold material just sloughs off. This material doesn't do that, but it's much, much more efficient. I would never be able to get my artwork out of most of my molds if I wasn't able to soak it. There's just no way to remove the material safely from such fragile objects. Thank you. That's a great question. I mean, it's sort of full circle. You know, I wish we had all of those things here to show people, but we don't even have all of those things yet in our third day of our workshop. So thank you very much.